Not anybody want to give me a better definition than the wrong definition?
Okay, I'll go with one.
How about we'll start with examples? Here's an example of a parallelogram. Parallelogram. That's a parallelogram. Parallel. Hence the name parallelogram. The definition has to talk about parallel lines. Everybody want to give me a definition of parallelogram? Do not use the word perpendicular. Opposite sides are parallel in a parallelogram. It is a quadrilateral, so what does that mean? 4 sides, so a 4-sided figure with both pairs of opposite sides being parallel. So I drew a lovely example. Could you give me another shape that has opposite sides that are parallel? Maybe that has the right angles in it. Wrong, because a triangle is not a quadrilateral. Is a square a parallelogram? Are opposite sides parallel in a square? A square is a parallelogram. What? So yes. A rhombus. Do you remember what a rhombus is? A rhombus is defined as just having 4 sides that are the same. So like, it's a parallelogram where all sides are congruent. Does that make sense? Can you think of any other shapes that we know that are parallelograms? A rectangle, right? A rectangle is defined as a parallelogram with 4 right angles and opposite sides are congruent. So this is when we get into all these words that as we go through this chapter we're going to talk about. Every square is a parallelogram, but not every parallelogram. A rectangle, every square is a rectangle, but not every rectangle is a square. Okay? Again, like we said, Venn diagram. So, there's lots of types of parallelograms. So, parallelograms have to have parallel sides. A square is a parallelogram, but not all parallelograms are squares. So just kind of be aware of that. There are tons of properties of parallelograms. I'm going to give you a lot of properties of parallelograms today, and you're going to be like, oh, that's true for squares too. Oh, that's true for rectangles too. Because they're all parallelograms too. Okay? So, I try to not make it go a lot out here. In a parallelogram, not only are opposite sides parallel, but if a quadrilateral is a parallelogram, then opposite sides are also congruent. So every parallelogram, opposite sides are congruent. So I wrote, this is what the book says for abbreviations. They just draw a picture of a parallelogram for a parallelogram. Just like for a triangle, they draw a triangle. And what's there on the abbreviation is exactly what's up here in this sentence. So if you don't really care about the abbreviation, you don't have to write it. But using this as a picture, JKLM is a parallelogram. If they tell you it's a parallelogram, you know right away that JK is perpendicular, congruent to ML, and we also know that JM is congruent to KL. So if they tell you it's a parallelogram, then you know that. You can assume that. But that's why they have to tell you the word is a parallelogram. You can't just say it looks like a parallelogram, but if the information tells you it's a parallelogram. What else do we know? In a parallelogram, opposite angles are always congruent. Opposite angles, meaning angle K and angle M are going to be congruent, angle J and angle L are congruent. So again, opposite angles are congruent if you want to do the shorthand there. You don't have to do the shorthand if you want. would be easy to prove theorem 6.4 here, because if we're talking about parallel lines, could we talk about a transversal running through it? Right? We could talk about all these relationships between angles, parallel lines, and do that. And the same thing goes with 6.5. Not only are opposite angles congruent in a parallelogram, but consecutive angles, that means angles right next to each other, are supplementary. So, I'm thinking if you can write that or not. So in this one, so it's like not opposite angles, all the other ones are consecutive angles, x and y, x with y, y with x, y with x. In this picture, x plus y, no matter which x or y you choose, will add up to 180. So just think about in a parallelogram, they don't have to give you much information, and you can tell them a lot of things because all of these things are true because the opposite sides are parallel. And then the last one kind of builds off 6.4 and 6.5. The last one says, if a parallelogram has one right angle, then it has 4 right angles. Let's think about why that's true. If it has one right angle, what do we know about opposite angles? They're the same. So if this is right angle, this is a right angle. And what do we know about consecutive angles? Consecutive angles are supplementary. So if this is 90, then its supplement would also be 90. So it'd be really easy to prove 6.6 using 6.4 and 6.5. So if you have one right angle, you have all right angles. This is why paralleling it helps. Parallelogram gives her a whole chapter to themselves. This is just about parallelograms. I think you got it. So rhombi, like you said, those control. Sorry, you slept my thoughts. Three parts. I know, he doesn't wake up at all. I know, but he's really asleep. I know, that's what I think. Alright, so it says this is a symbol for parallelogram. So they're telling us that this is parallelogram ABCD. They tell us that angle B is 32 degrees. They tell us that AB is 80 inches. And they tell us that BC is 15 inches. So based off the properties I just gave you, don't yell it out, but there's 3 things that you should be able to say based on what we know. It says find AB, it says find the measure of angle C, and find the measure of angle D. Using the properties, see if you can do that really quickly before we move on. Sydney, what did you get for AD? Like for part A, for class AD. Right, good percent. It's 15, right? And if this is 15, opposite sides are congruent, it means that this is also 15 inches. Taylor, what did you get for angle C? So what would you do to find angle C?
Well, first off,
the other two have to be the same. That would work. Anybody doing something different? Audrey? Yeah. Consecutive angles are supplementary, which means that angle A and angle C have to be supplementary to angle B, which means you could just take 180 minus 32. Chandler, you would have still got the right answer. There's more work to do, right? That's that 148. That's 148. And then angle D might be an easy one to do. Alan? Is this opposite angles? You could add them all up and you can do all work. Right? That's not so bad, right? We heart parallelograms. Alright, I didn't even leave any blanks for you to fill in here because I was stressed that we were going to be running out of time, and I was right. Diagonals of parallelograms. If a quadrilateral is a parallelogram, then its diagonals bisect each other. What does that mean, if the diagonals bisect each other? Yeah, no, you're right. I'm just looking at it. So the diagonals cross, and where they cross is going to be at the midpoint of each of those diagonals. So they mark that these two are congruent, but we could also say that we know AP is congruent to PC, because that's diagonal bisected, and this diagonal, would be bisected as well. Which are things that you guys have been wanting to say for a long time, and I wouldn't let you say, because you're like, well, it looks like it bisected. Now, with a parallelogram, you can say, hi, Brandon, welcome back. We were all talking about you and staring at you, and we thought you were just going to smile, but you were out. We were all staring at you, and they're like, man, it looks like he's going to smile any minute. I bet when he wakes up, his neck's going to hurt. You didn't hear any of that. Yeah, we talked about you for a while, and you were... Oh my gosh. Okay. What else we can say is if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles, which should make sense. If opposite sides are congruent, right? So we know already in a parallelogram that this side is congruent to this side, yes? And we know this side is congruent to this side. And if we cut it with either diagonal, do we know that the diagonal is congruent to itself because of the reflexive property? Which means that makes sense. It's true, and that's how they can prove it. That's the proof for this, is we know that that's congruent to itself. So if you have the diagonal drawn in, then you can say that you've broken that up into two congruent triangles. Yes? So, this means we can do some proofs. It also means we can do some questions like example 2. Look, I combined this all into one question. Look at this picture. There's a lot of stuff in there, right? It says, if WXYZ is a parallelogram, which means if it's a parallelogram, all the things we've learned are true. Find the values of R, S, and T. So there's 3 things to find there. So I think we could just do a step at a time. So let's look at R. Where's R? For R, and what do we know about 4R? These are opposite sides, yes. So they're parallel, they're also congruent. So that we know 4R equals 18. Should we freak out because it doesn't work out nicely? Divide by 2, that would be 9 halves. 4.5 for the decimal. Non-decimal. I just heard thinking.
That is decimal.
I'm anti-decimal. Well, it's still okay. I would never argue wrong for a decimal, but I just like that. Okay, R good. Who wants to talk about S? Garrett. Because the diagonals bisect each other, right? If I subtract 7s over, that's just going to be 1s, right? If you subtract 8s, then we have to subtract 3. I think it's just... I usually make my s's cursive because they tend to look like my phone. Alright, we got R, we got S. Who's up for T? Grace, I vote you. This one and this one, are those congruent? Okay, think about it, there's a lot of stuff going on. So think about, here's a parallel line, here's a parallel line. The diagonal becomes like the transversal, right? And so you can think about those are alternate interior angles. Or you can use the theorem about that the diagonal breaks it up into two congruent triangles, and corresponding parts of congruent triangles are congruent. Oh my gosh, it's all from that. But, yes, 2t has to be equal to 18 degrees, which makes t equal to 9. So look at the next one. Maybe we don't have to write this whole paragraph throughout, but I can give you a clue. So what about this one? It says, given parallelogram ABCD, AC and BD are the diagonals, and point P is the intersection of AC and BD. Prove that AC and BD bisect each other. Which means, I think they're trying to have us prove that theorem. Because we have a theorem that says that's true now, right? So sometimes in the homework, they like to give you the, like, they want you to prove the theorem. If they ever ask you to prove the theorem, so like next to it, it would say like, theorem 6.4. It means you can't use the theorem as its proof. They want you to prove the theorem based on other things. Does that make sense? Which means I think they want you to prove that the two triangles, like if you could prove that two triangles are congruent to each other, then we could prove the whatever. So, AC is here and BD is here, so we want to prove that these are congruent to each other. So we know already, do we know that AD is congruent to BC? How do we know that? It's a parallelogram, right? I hate paragraph proofs, because who wants to write a full paragraph? So I would be like, I know, well, here's my given. AD is congruent to BC because it's a... I could just do that when I write the word parallelogram. Could I use the whole idea of parallel lines and making it transversal to prove that some angles are congruent to each other? If I looked at this line and this line with this transversal going through it, could I say that this angle is congruent to this angle? Could I use this transversal to show that this angle is congruent to this angle? So I could use alternate interior angles to prove that those two angles are congruent? I really don't want to write alternate. The angles DAP is congruent to angle BCP, and that angle BBA is congruent to angle PCB. So I used the definition of a parallelogram, or the property of a parallelogram, I've used alternate interior angles, and I'm gonna erase some of this because I'm trying to prove that these two triangles are congruent. Because if I can prove they're congruent, then I could use the CPCTC. So look what I have. Angle, side angle. Do I have angle, side angle? Yeah. So I could say that I know triangle APD is congruent to triangle CPD by angle, side angle. And if I know they're congruent, I know all their corresponding parts are congruent, which means I know that this side is congruent to this side, and this side is congruent to this side, which proves that they bisect each other. That's a proof of why that theorem's true. Alright, so maybe we should write that. By CPCTC. I need to see the CC. By CPCTC, AP is congruent to CP, and BP is congruent to DP. Therefore, AC and DP bisect each other are the definition of bisect. It's kind of a long proof, but to me, it makes sense because of all the things that we've learned, which is why yesterday when people keep asking me, like, do I need to save anything from last semester, I'm really going to go back and use those papers. But when we do proofs, side angle side, that stuff's going to show up. Alternate interior angles, that's going to show up. CPCTC, that's going to show up. And so just know that that is going to show up. I think I gave you one proof today. I don't know where. Maybe two, I don't remember. But the majority of it is algebra stuff, but I don't want you to forget about this idea of proving things. And so 9 through 12 and 15 through 20, I think those are all, like 9 through 12 is all about one picture, like our first example, where you're just using the properties. 15 through 20, just using the properties. And then I think 26 is the proof, and then 47 and 48 are multiple choice at the end. So really not that bad. You might want to use a calculator for some of this, but if you have a phone, you have a calculator on it. So hopefully you have the calculator that you can do stuff with. Okay? They do. They all